Welcome back to Mr. Vaughn's classroom. Please take a moment, hit the subscribe button, and give this video a thumbs up if you find it helpful. Today we're continuing to look at Unit 4 on functions, and this is Lesson 13, Part 1 of absolute value functions. Our learning goal today is to make some guesses and see how good they are. We have 3 learning targets. As we go through the practice problems, keep these 3 learning targets in the front of your mind. And by the end of the lesson, if you do not feel comfortable making any of these statements, please drop a comment below and I'll get back to you with any clarification you need. Learning target number 1. Given a set of numerical guesses and a target number, I can calculate absolute errors and create a scatter plot of the data. This simply means if I give you a list of guesses and I give you what the number should have been, you can tell me how far away those guesses are, not caring whether they are below or above the given number, and then be able to plot those on a scatter plot. Learning target number 2. I can analyze and describe features of a scatter plot that show absolute error data. And learning target number 3. I can describe the general relationship between guesses and absolute errors using words or equations. Simply means you can create an oral argument or an oral explanation about the distance between the guess and the real number, or you can show that same thing by writing an equation. Our first glossary term is absolute value. The absolute value of a number is its distance from 0 on the number line. So, this simply means we don't care whether it's below the 0 or above the 0. We only care how far from 0 it is. So, whether I'm 5 above at positive 5 or whether I'm 5 below at negative 5, I don't care about the sign. I just care about the fact that I'm 5 numbers away from 0. Second glossary term is domain. The domain of a function is the set of all its possible input values. So you need to think logically in the situation given to you, what numbers are you allowed to use for inputs? Things such as whole numbers, partial numbers, positive numbers, negative numbers. Is the number I'm looking for going to be on the bottom of a fraction? Is it going to be inside of a radical symbol? So you've got to think about a bunch of different limitations on what numbers are allowed to be inputs, and then that gives you your domain. Our third glossary term is piecewise function. A piecewise function is a function defined using different expressions for different intervals in its domain. In other words, I'm going to have more than one rule for the function, but which rule I use is determined by the input that I'm currently using. So as my input changes, the rule I use to find my output can also change. And glossary term number 4 is range. The range of a function is the set of all the possible output values. Again, think about it logically. Is my output, does it have to be whole numbers? Can it be partial numbers? Does it have to be positive? Could it be negative? Does it need to be a multiple of something? Or is it allowed to hold the values in between? These are all logical ways you need to think about the specific situation you're talking about to determine what numbers are allowed to be in your range. Now we can begin the practice problems for Unit 4, Lesson 13, Absolute Value Functions, Part 1. A group of 10 friends played a number guessing game. They were asked to pick a number between 1 and 20. The person closest to the target number wins. 10 people made these guesses. Number 1 says the actual number was 14. Complete the table with the absolute guessing errors. So when we say absolute guessing errors, this means we only care how far away the number is from the actual number of 14. We do not care if that number was below 14 or above 14, only how far away. So every single one of our answers is going to be a positive answer. So first we have 2, and 2 is 12 away from 14. Next we have 15. 15 is only 1 away from 14. Next guess was 10, and 10 is 4 away from 14. The fourth guess was 8, and 8 is 6 away from 14. The fifth guess was 12, and 12 is 2 away from 14. The sixth guess was 19, and 19 is 5 away from 14. The seventh guess was 20, and 20 is 6 away from 14. The eighth guess was 5, and 5 is 9 away from 14. The ninth guess was 7, and 7 is 7 away from 14. And the final guess was 9, and 9 is 5 away from 14. Number 2. Graph the guess and absolute guessing errors. So we can see that the guess, which is this top row, is the x value, and we can see that the absolute guessing error, which is the bottom row, that is the y value. So the first guess has 2, 12. So we go over to 2, up to 12, and we put a point. The next guess was 15, which was 1 away. So we're going to go over to 15 and up to 1 and put a point. The third guess was 10, 4. So we go over to 10 and up to 4. The fourth guess was 8, 6. We go over to 8, up to 6, and put a point. Then we have 12, 2, over 12, up to 2. then 19.5 over to 19 up to 5, 26 over to 20 up to 6, 5, 9 over to 5 up to 9, 7, 7 over to 7 up to 7, and finally 9, 5 over to 9 up to 5. And now we have all of the points. Number 3 asks, is the absolute guessing error a function of the guess? There's my magic words again. A function of. That means whatever comes before those words is my output. So that's absolute guessing error. And whatever comes after those words, the guess, is the input. Remember that a function, one input, has only one output. So the answer for this would be yes, because each guess has only one absolute guessing error. That means this is a function. If you have any questions about this practice problem, please drop a comment below and I'll get back to you with any clarification you might need. Our next practice problem says, a bag of walnuts from a food producer are advertised to weigh 500 grams each. In a certain batch of 20 bags, most bags have an absolute error that is less than 4 grams. Could this scatter plot represent those 20 bags and their absolute errors? Explain your reasoning. So, I know that my middle number is going to be 500. So 500 minus 4 would be 496, and 500 plus 4 would be 504. So that is going to give me my dividing lines. So right around in here, and right around in here. Now this said, most bags have an absolute error that is less than 4 grams. So they would need to have most points be inside these lines. So my answers would need to be inside this set of dotted lines. And if I compare them, it appears that there's probably more outside of this area than inside of this area. So we would say no. It appears most bags have an absolute error of 4 grams or more in this batch. So this would not be the batch that they were talking about in the word problem, where most of the bags had an error that was less than 4 grams. If you have any questions about how to answer a practice problem like this, please drop a comment below and I'll get back to you with any clarification you might need. Our last practice problem, the class guessed how many objects were placed in a mason jar. The graph displays the class results with an actual number of 47. Suppose a mistake was made and the actual number is 45. Explain how the graph would change given the new actual number. So the first thing I want to point out is this V shape that we see happen. Absolute value functions will always form a V shape centered at the correct answer. So here we have a V shape graph centered at the point 47, 0. Because a guess of 47 would have an absolute guessing error of 0 if 47 was correct. Now, if there was a mistake and the real number was 45, we would still have that V-shape graph because it's still an absolute value graph. But this time, it would be centered at the point 45, 0. Because now a guess of 45 would have an absolute guessing error of 0. So the graph would shift 2 units to the left and still be a V-shape graph. An absolute value function will produce this V-shaped graph centered at the actual value. If you have any questions about anything we covered in today's lesson, please leave a comment below and I'll get back to you with any clarification I can help you with. Before we finish this lesson, let's go back and look at our learning targets and make sure you understand what you're doing. Learning target number 1, given a set of numerical guesses and a target number, I can calculate absolute errors and create a scatter plot of the data. So if you feel that you can calculate the absolute error, how far the guess is from the target number, and if you feel you can then plot those on a graph and create that V-shaped graph, then you are right where you should be. Learning target number 2, I can analyze and describe features of a scatter plot that shows absolute error data. Can you notice the V shape? Do you understand that it will be centered on the x-intercept, where you're going to have the real number and a absolute guessing error of 0? Do you understand how that V shape would shift if there was a change in what the actual number was? If so, then you're right where you should be. And learning target number 3, I can describe the general relationship between guesses and absolute errors using words or equations. Are you able to explain that the relationship is going to be the positive value of how far away the guess is from the target number? Are you able to use equations, whether that's subtraction or addition, to figure out what that difference is? If so, you're right where you should be. Again, if you need any more help, please drop a comment below, hit subscribe, give this video a thumbs up, and I look forward to seeing you in the next lesson.